actually really glad that I'm following the Gutex presentation because I love Gutex. Also, I've worked with it, and my favorite assembly for a cold climate is probably straw bale with Gutex on the exterior. It's such a great product, and I really wish it was being manufactured in the US. I can't wait till they get it up and running. So CLF Seattle folks asked me to talk about straw bale construction and to touch on straw clay and temp lime a little bit as well, and what are the challenges with it and how I've overcome them in my career. And I'll talk a lot about how I haven't overcome them yet and how I'm working on it, but how I'm prepared to help anybody with it. I think, honestly, I'm kind of just a kid still, building forts in the backyard. I find a lot of playfulness in design, and there's a lot of empowerment in building. And I know we're talking about carbon today, but it's really not just about carbon. And one of the most impactful experiences that I ever had in my career was working on a Pueblo rehabilitation affordable housing project at Okeowinge in New Mexico. The tribal council, the Tribal Cultural Council, had selected to reincorporate their yearly tradition of plastering with clay from their land. And so the photo on the right is like, I don't know how many years ago. And the photo on the right is the project 10 years ago. And that seeing this happen was just very, very powerful for me. I went into architecture because I learned that we could build buildings with things like straw and clay, and it hasn't been a straight path for me at all. Being an 18-year-old girl many years ago, architecture seemed a little more approachable than construction, so that was the path I chose. But I've been working in construction and architecture sort of back and forth throughout the years and taking any opportunities I could get to learn more about these materials and how to implement them into conventional buildings. And so I've sort of gained a little bit of an expertise with both my passive house learning and my in the field alternative construction learning, how to pair the two together and identify appropriate ways and the right assemblies and what the challenges are and how to overcome them. So this is a couple of projects that I've been working on recently. One in Victor, Idaho. This is an ICF foundation with straw bales above. Just doing a little demonstration on making and mixing and applying a lime plaster. And then on the right is installing straw bales and Kalispell in a very conventional home. You can see the post and beam frame with straw bale infill, and we've compressed the bales and we're just really forcing that last one in, so it's a really tight wall. When we're talking about the challenges, I think there's a few things that, and specific to straw bale or any sort of earthen or very natural materials, I feel that I really need to address some of these myths that we perceive as challenges that are not actually challenges. If you can't get past these with a client or a contractor, you're dead in the water. And these come up all the time. People always bring up, oh, 3 little pigs, and like, what about mice? And I just want to start by reassuring, like, let's look at the big picture and reality. So the reality is that stud frame buildings are notorious for pests, termites, mice. They're little cavities, especially with bats compared to like some sort of dense pack insulation. They're great places for pests. In straw bale construction, that if you were going to take on a project like this, because everybody's already coming with that mindset from these crazy stories that we see online of like, build this hippie home for $5,000, and people are always concerned about mice running around in the straw bale walls. And in order to break that cycle or that myth, as a designer working with these materials, you have to be willing to do an impeccable job, because you've got a big sort of cultural gap to bridge initially. So I advocate that you be kind of a little bit of a perfectionist. So you're detailing, this is just a pretty typical foundation detail that you might see in a cold climate. There's no insulation on the foundation. It's missing some other things, but it does indicate that you've got the bales raised above the ground plane, and they are going to be very dense in there, and you've got your plaster bridging all those gaps, and there's just things to think about. You need to consider good design principles in an unconventional building, even more so than you do in a conventional building. Fire. Oh, but I want to say one more thing about this, that honestly, like, straw is essentially little tiny particles of silica. It has zero nutritional value for anybody. It's far less attractive than wood or cellulose for insects. Mice love to run around in straw, like out in the fields, but as long as you can keep them from getting into the house, same as with a stud frame building, they're not an issue. Fire is sort of similar in terms of like, stud bays are really great chimneys. So if we have those stud bays filled with something dense, i.e. straw, they are not going to be chimneys. And it's going to work very well. So I don't know if any of you are familiar with Argentile Architects, but they have done a lot of reporting on some of their buildings that have withstood or had to go through fires in California recently. You can see the building on the left, the building on the right, it's the same building. The parts that are disappeared were the stud framed areas. And this was a building that the fire came right up to and just sort of licked the plaster. But with straw bales, I'm really talking about straw as an insulation within a conventional framed system. You can build a very conventional looking straw bale building that you couldn't tell it was straw at all, other than it might have thick walls. And honestly, if we're using double stud walls with cellulose or Gutex or any other biogenic insulation, we have thick walls. We just have to embrace that. It's one of the great things about this type of construction. I think there's great opportunities with it. But the other thing that straw does offer, or a straw bale, in fact, is it's a great substrate for a very thick mineral plaster, which A, is completely non-combustible, and B, there's all sorts of like potential biophilic and health benefits from it, which I'll get to if we have more time. Moisture. So again, like in a conventional or an unconventional building, you have to be very, very vigilant in your understanding of the assembly and how the moisture vapor is going to move through it, how the material can hold moisture and then let it go over time. One of the things that we do in straw bale construction is we try to isolate any plumbing to keep it out of the straw bale walls, which really is probably a good idea in any insulative cavity. Like, I always try to keep plumbing outside of any wall, exterior wall. Keep it in the interior cavities. It's just a better strategy. I actually have had to do a repair where there was a catastrophic a condensation unit on a roof leaked down into the wall. It would have been just as catastrophic in any other building. And it's painful to have to do a repair like that. There's no doubt about it. But what I learned was that with this kind of construction, you can reuse the plasters. You can put the straw bales in the garden and just replace them. There is nothing that has to go to the landfill. There is no chemical pollution whatsoever. This graphic just sort of describes what I was talking about earlier, that you need to understand how moisture is going to move through or interact with the surfaces. And hopefully we all have a decent understanding of this. You do have to be vigilant about it. I think in a climate like Seattle especially, you probably can get away with less than I can get away with in the desert in Idaho. So it is important. This is just a study of a woofie done by someone in Europe on a straw bale wall. And a little secret is that if you're using a 475 material in your building, the owner or the contractor who's purchasing the material can request a woofie be done of your assembly, and 475 will do that for free. Maybe don't tell them I said that, but it's a good trick. Another thing is just like being vigilant about flashing and keeping the straw bales out of any ground precipitation. So in Idaho, especially where I am near Jackson, we have 3+ feet of snow for months on the ground, and then a lot of freeze thaw that happens. So keeping the bales a certain amount off the ground is great. And you can find other opportunities. Like in this case, you see you've got a framed wall below. That's a super easy electrical chase. Window flashing, just making sure that you're paying attention to protecting the wood and the sequence of installing the flashing around windows when you're installing. All right, the next potential hurdle or like challenge or issue or opportunity thing that you have to deal with in a straw bale building is a framework for the bales, because you can do a straw bale load bearing building, but they're restricted to very small buildings. And most of us are doing something at least a little more complicated, if not much more complicated. So one opportunity is panelization. This has happened in the past 5 years and longer than that in Europe. There are 2 companies back east in the US who are doing panels. New Frameworks is one, and something Croft is the other. I can't remember their full name, and I wish I could highlight them more here, but they're both great companies. They do some combination of straw and cellulose sometimes when it's needed, and you can see that in between the framing, you've got essentially Gutex or some kind of wood fiber board here taking up the space. It's a panel, a straw bale panel is essentially like a double stud wall. It's really not rocket science. There's nothing super tricky about it. And there's opportunities again for plaster, or you can put whatever whatever finish substrate on it you want. In a high seismic zone, you may need shear support. Well, you will need shear support. And in our high seismic / super high snow load zone, 90 pounds per foot, we have to use sheathing. So I should have said with the New Frameworks panels we do. And back east, they're most often using sheathing anymore, because then it's an opportunity to just apply a rain screen on the outside and do wood siding. With these ones from Eka Kakon in Slovakia, we designed a building that didn't actually get built in panels yet, but we learned that because of the cross bracing that's built into the system, even in our high seismic and snow zone, we don't need sheathing, which is really kind of cool, because then we could apply plaster to the exterior if you wanted to. This is another framing system that Arctilt Architects uses often. You can't see the framing behind the little webs or ribs of plywood on the face of it, but it's basically just, they use these big 3-string bales that are, I don't know, like 18 inches wide. The framing is just slightly modified from 16 inches to 18 on center. And the bales fit very nicely in there. And then they can just use this like spline between them. This is a system called Straw Cell. And I don't know if any of you are trying to achieve passive house results in cold climates. I was working on that a lot with Love Shack. And I'll get into R value a little bit more, but just a regular 2-string 14-inch straw bale isn't going to give you the R value that you need in, say, climate zone 7 for passive house. So adding a framed layer of cellulose works very well. And then the straw bales can just be supported by the floor structure. In this situation, or in any of the panel situations, again, you do have the opportunity to do a plaster on the inside if you want. Also, add in extra framing and apply sheetrock. With the panels, it's easier because you automatically have that sort of double stud framing situation. Another challenge that people often run into or say they run into is I'm kind of combining insurance and framing into one. I have not found insurance to be much of a problem, but the Colorado or California Straw Bale Association is in process of doing an insurance study, basically creating a database of people who have built or owned straw bale homes and who provided the insurance, so that others who want to do the same thing can more easily just go to that same insurance company without having to do their own research. These are things that are just as much a problem with passive house or any sort of innovative new sustainable methodology. Banks, our market doesn't recognize them, unfortunately, doesn't recognize that there is maybe a little bit more investment to build a super high performing home, a super sustainable home or building, and we just need more comps. So the more that we can sort of gather networks of people together to identify comps in every community, it will be easier for people to finance. You can also just say, hey, I'm building a post and beam building with cellulose insulation, and depending on the bank, they may or may not have a problem with it. The most real hurdle and challenge that we found at Love Shack, and this has led me to switch paths, is the lack of contractors. I've designed many more straw bale buildings that didn't end up being constructed as straw bale in the end. We'd kind of go through like schematic design with a client who was asking for this, and then start working with the contractor. And maybe there was, in my pretty remote region, which is not the same in Seattle, there was just one contractor within the 2 towns that was willing and able to do a straw bale install and coordinate the plastering. So I am embarking on this new career path to be more in the field and providing more education to architects and contractors and homeowners, kind of sort of like taking the risk away from a general contractor. If you have a general contractor who's interested, an owner who's interested, but they don't have experience with it, they're not sure how to estimate it, it's scary, I am a person who could come in and say, I'll help you estimate it, and I will, I can lead the install. Obviously, I can't do it by myself, but I will teach others how, teach the crew how. I'll be working for an architect in Jackson, identifying the layers of their earth and floor assembly, and then leading the install of that this fall and winter. These other websites that I have up here are really great resources, and I'll flip through and just show you their websites real quickly to show you how much information is out there. CASBA, they have a conference every year in Sonoma, usually. It's super fun to go to. It's a beautiful place. I'm here in Boulder, Colorado, actually, right now for the Rocky Mountain Natural Building Conference. And I'm at the library right now, but later today I'll be surrounded by people who are making a living designing and building straw bale buildings. The Carbon Smart Materials palette is actually through Architecture 2030. not exactly sure the partnership. I think it was a project of 2030, but it's got some not super detailed information, but some high level information that could be helpful. The NITO project, it's this family, I think they're in Arizona, and they are producing these amazingly gorgeous videos that are pretty educational. The Last Straw Journal was started many, many years ago by some of the straw bale pioneers, but has been sort of re-engineered and re-pioneered by some folks who graduated from Auburn University's, I can't remember the name of that amazing program, the Rural Studio. So they're doing a great job. It's very like sexy and good eye candy and fun to look through. All right, so there are resources out there. Sourcing materials. This is not necessarily a challenge, but it is a different type of sourcing materials than most of us are familiar with. As an architect, you typically just spec something on your drawings or in a project manual, and it's very technical. And those do exist for straw bale and some other natural material systems like cob. You can find them, but if you were just part of the design team and figuring out where these things are going to come from in the first place, one sort of obvious or easy answer for straw bales is your state Department of Transportation. They are very often used as mulch on their construction projects, and they often have very tight, clean, right-sized bales. And they probably have farmers throughout the state. And then excavators for sourcing clay. Every project has an excavator, and every excavator knows where the clay is in your community. So it's really not that hard. You do need someone to help look at the clay, examine the clay, maybe do some test samples and confirm that it's actually gonna be usable clay, but it's not rocket science. If you do it once or twice, you'll know, and you'll be able to do it in the future. All right, if we still have a little time, I'd like to talk a bit more about some of the benefits of using these materials. Adam, will you just give me like a thumbs up if it's okay? Okay, great. So I don't want to go too much into biophilia. I don't have statistics and things, but I know that it is, it's very important. And I guess what I want to say is that the majority of human beings on the earth who have lived on the earth have lived in buildings that were built with clay and lime. And in architecture and engineering school and in our industry, we don't learn anything about them. But it is in our DNA. We want these things. It makes us feel more at home to be around materials that are natural, that are not chemically derived, that are not plastic, and that we can tell that a human touched. Not to mention the lack of chemicals. Again, I'm not necessarily promoting that we build 100% all natural homes with some organic foundation and roof system. I'm absolutely not. I'm just promoting that we try to use these materials where they are appropriate and easy to use, and limit the chemicals that we put in our homes. We spend 90% of our time indoors, and in the US, chemicals are not really regulated. Even asbestos is not regulated and eliminated from the industry. So there are some things that we can do relatively easily without trying to do everything perfectly. And then I also want to mention, it's a factor of social justice. No building is neutral. No, architecture is not neutral. Construction is not neutral. Every material that we use has an impact on the place that it came from and the people and the ecosystem where it came from. We have a huge organic food market in this country. We all think about what we're putting in our bodies, and yet as designers, we're building homes or commercial buildings or institutional buildings that are millions and millions of dollars and have huge impact on the economy and the environment, and it all trickles down. So the more we can use local resources and things that are just not harmful, the better. I'm not going to go into the red list, but it's obviously a thing. And I think the last thing that I want to land on is performance and R-value. Let me just, well, I'll say a little bit about carbon. I know you guys, I'm kind of preaching to the choir about carbon. That's why you're here. But performance and R-value, I do want to clarify, straw is not the highest R-value material out there. It is dense, and that's one of the great things about it. But like I said, in a cold climate, we have to do additional things to even achieve that level of R-value. That being said, R-value is not the be-all, end-all. It cannot be. We have to consider everything, both, yeah. We have to consider both the performance of the building as well as the embodied carbon. And so you all are familiar with the beam calculator, so you're probably familiar with Chris Magwood's work and his data showing that if we build super high performing homes with the wrong materials, we are doing more harm than good. We're finding the right balance here. And that leads me to carbon, and I just want to leave you with this, that straw bale is or straw in general and hemp are both so carbon negative that Love Shack did a straw bale panel project with New Frameworks panels. The panels were shipped from Vermont most of the way across the country. And I don't have the data for you, but even with that, a 3,000 square foot residence, it was like, they did the carbon calculation and it was still the equivalent of taking 3 cars off the road for a year or so. So there's a lot of potential here to use this material. And my goal is to help us as professionals be able to do it and do it faster.